Alright, let's look at the homework 6.3, problem number 9. Alright, so we want to find the n value for trapezoidal rule and the Simpson's rule so that error is going to be guaranteed to be less than 0.0001. Alright, so let's do that. Alright, so we're going to use this error-bound formulas. Alright, so let's do part A, trapezoidal rule. Alright, so I'm going to use GeoGebra here. Alright, so first I'm going to open up a view called CAS, Computer Algebra System. So open that up. And we don't need graphics here, we don't need algebra here, so I'm going to close those up. Alright, then first I'm going to define a function f of x, so f of x colon equals 1 over x. Hit enter. Alright, now GeoGebra knows what the f of x is. Alright, so I'm going to find the second derivative. It's actually quite simple. We do f double prime of x. Alright, then hit enter. Alright, so it computes the second derivative for us. Alright, so we want to find the maximum value x between 2 and 5. So the maximum value is going to be when the denominator is the smallest possible. In this case, x equals 2. So what you can do is we can actually go here and then I plug in 2 there. Right? So the maximum value of a second derivative is going to be 1/4. Right? So let's use that number to compute this. Right? So we have error bound for trapezoid rule, right? And this is less than or equal to, right? In this case, b is 5. So b value is right here. So 5 minus a value is 2. So 5 minus 2 and cubed and over 12 times n squared. We are trying to find that n. Alright, so we just found that the largest value of second derivative would be 1/4. Right, so that was given by GeoGebra there. Right, then what we want to do is we want to make sure that this is less than 0.0001. Alright, so let's solve for n here. Alright, so first thing I would do is I'm going to take the reciprocal of both sides. So you're going to have, let's see, 12 on top, n squared on top, and the 4 on top, over, right? So we're going to 5 minus 2 is 3, and you have to cube that. And this is going to be, so reciprocal of 0.0001 is actually 10,000, right? When you take the reciprocal, we have to change the direction of inequality there, right? So we got that. All right, so the next step is I'm going to get rid of, let's see, 3 cubed. So I'm going to multiply by, right, 3 cubed. And then over, I have to get rid of 12, so divide by 12, I have to get rid of 4 there. So that way we have just n squared is greater than 10,000 times 3 cubed over 12 times 4, right? We can actually simplify a little bit by hand. So let's say I'm going to use one of the three. Divide by 3, so that will be 2. Divide by 3, that will give you 4, right? All right, then the last step would be we can just take the square root of both sides. So we take the square root so that the square is gone. So you have n is greater than square root of, right, 10,000 times 3 squared over 4 squared, right? So let's compute that value, right? So I'm going to square root. So square root of, right, 10,000, 1, 2, 3, 4 zeros, times 3 squared divided by 4 squared. All right, so hit enter. All right, so it came out to be 75. Let's see, so what's the precision there? All right, so is it, it's actually 75 exactly. All right, so in order to make sure that this is going to be greater than, so it has to be greater than 75. So we're gonna, I think I'm gonna put 76 there. 76. All right, so let's check the answer. Submit for testing. All right, it actually came out wrong, so it's going to be 75 probably. So I'm going to check that. Submit for testing. All right, it came back, and it's actually 75 is the answer. So I thought this would be 76 because this came out to be exactly 75. But let's see, let's go less than. Yeah, I think that'll be fine. All right, so it's 75. All right, and Simpson's rule, it's very similar. All right, so I'm gonna just open up GeoGebra. All right, if you take the fourth derivative, and you're gonna get this. All right, so it's a 24 over x to the fifth. And if you want to make this as big as possible, I'm gonna plug in 2. Right, 2 is the smallest value here. So plug in 2 and hit that. So we get the 3/4. All right, so we're gonna do the very similar thing. All right, so you have the error bound for Simpson's rule. All right, so b minus a is a 3. So you have a 3 to the 5th power over 180 n to the 4th power. And we found that the maximum of the 4th derivative is 3/4. Right? We have that. All right, then we want this to be less than 0.0001. All right, so let's solve this. All right, take the reciprocal of both sides. So you have a 180 n to the 4th times 4 over 3 to the 5th times 3, and that's greater than 10,000. Right? Then I'm going to, let's see, multiply by, so I'm going to get rid of 3, let's see, so that's going to be 3 to the 6th over, and 180 times 4. Right? So we get the n to the 4th is greater than 10,000, and then multiply by 3 to the 6th power and 180 times 4, let's see, 4. Right? Then last step would be we can just take the 4th root of both sides. So it's n is greater than 4th root of 10,000 and 3 to the 6th power 180 times 4. Right? So let's compute this value. Right? So we need to find, let's see, 4th root. So it's going to be raised it to the 1/4 power. Right? 10,000. So 10,000 times. Right? So we have 3 to the 6th over 180 and times 4. Right? So you have 3 to the 6th power divided by 180 times 4. Right? Then hit enter. Right? Then I'm going to actually change it to so I'm going to have to turn it into a numeric value. So I'm going to just say numeric then here, hit enter. All right, so it came out to be 10.03. So it's a slightly over 10. So I want to say 11, but since Simpson's rule only takes an even number, so this is going to be 12. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.